This presentation provides an introduction to object-oriented programming. Object-oriented programming is a set of technical programming features that support building software in pieces. These pieces can be put together in different ways to produce large software systems. Without object-oriented programming, we built single monolithic software systems. As they got larger, it became difficult to make changes, fix defects, and find computers powerful enough to run them. Building software using object-oriented programming has many advantages. When software is built in pieces, multiple developers can work on different pieces at the same time. Using OOP, you can build larger systems in a smaller amount of time. Since each piece of software normally does a specific task, they are less complex than the entire system. This makes them easier to develop and with less defects. Some pieces of software needed to build a large system may already be built and can be used. This is often referred to as reuse. Each piece of software can test it individually before it is assembled. This makes testing easier. The pieces of software can be replicated. A piece of software can be written to perform a single function. In the large system, it can be used multiple times. In very large software system, the software cannot run on a single computer. In OOP, different pieces of software can run on different computers. Multiple programming languages support object-oriented programming, and many non-object-oriented programming languages have versions that support OOP. The syntax is often different in each language, but the concepts are basically the same. There are two very important terms in object-oriented programming that need to be understood. These terms are class and object. Many times people interchange them, but that have distinct definitions. A class is a collection of items that have something in common. An object is a specific item. For example, the word dog in a class. There are many things in the world that we call a dog. Snoopy is a single thing. He is specific. In this case, he is an object. In software, we use this concept to create classes and objects. Classes are templates for what a piece of software would look like. For example, you could have a class that is a bank account. In Java, the class would look like this: public class bank account. Once the class is created, objects can be created of that type. You can have an unlimited number of objects of class bank account. In Java, the object would look like this: bank account equals me new bank account. You can have other bank account objects. Bank account another equals new bank account. There are multiple methods to determine what classes should be made. One of the most common methods is to simply make classes that model the actual objects in the requirements. If the requirements discuss customers, bank accounts, deposits, withdrawals, etc., then make classes accordingly. If the requirements discuss avatars, monsters, and spaceship, then make classes avatar, monsters, and spaceships. This method makes it easy to match requirements to the software that implements them. Classes stores information and they can perform actions. Information is stored as attributes. Actions are performed as methods. Attributes are all of the characteristics of a class. If the class's human attributes could be age, height, name, social security number, etc. If the class's bank account attributes could be account number, balance, service fee, overdraft fee, etc. When an object is created of a class, the attributes can be assigned values. If the class is human, and we create an object called Bill of class human, then the age of Bill can be set to 12. If the class is bank account and we create an object called ACCT123 of class bank account, then the balance can be set to $10,000. In Java we can define a class with attributes like this: public class human, public int age, public string name. Here we create a class called human. Every human has an age which is an integer and a name which is a string. We can set the values of the attributes for objects of type human. Human Bill equals new human, human h2 equals new human, Bill age equals 12, Bill name equals new string, Bill h2 age equals 7. Classes can also do things. They can perform actions. This is done through methods. A human can talk, run, and sit. A bank account can return balance, accept deposits, and give out withdrawals. Here is an example in Java. Here we define the class name. In this case, bank account. Next we define the attributes. Balance stores the account balance. This is of type float. Account number and an integer that stores the account number of the account. The class has two methods: deposit and get balance. The deposit method is called a float. Value x is passed into the method. This is added to balance. The get balance method returns a float, which is the account balance. This shows how information can be passed into and out of classes. A class is a template for all of the possible objects of the class type. So, if we create a bank account class, it should contain all of the attributes and methods for all of the bank account for our customer. As stated earlier, when we actually use a class in a program, we do so by creating objects. In Java it is done this way. First we need a reference for out object. In this case our reference is BA1. This is how we will access out objects. We need to tell the Java compiler what type of reference this is. This is the name of the class. We need to instruct Java to create a new object. This new object will be of type bank account. Once the object is created, we can access attributes and methods. In this example, we created a bank account object BA1. We set its account number to 123. We set its balance to 0.0. Then we make two deposits, one for 5.1 and another for 10.1. Finally, we call getBalance and the balance is returned. Just like in the real world, there are many times that objects need to communicate with each other. One way that this can be done is through methods. Customer objects can request to withdraw money from ATM objects. Trader objects buy and sell stocks on stock exchanges.